the location of the roots, if this is the case 1, if both alpha and beta greater than k, then we should check for 3 things, man. What we can say for a into f of k, if it is said 1, and what we can say about delta, what we can say about minus b by 2a, and if 2 values are there, what about f of k1 into f of k2. These kind of inequalities we can find. So I said both alpha and beta greater than k. That means there are 2 cases. This like it will be there. So here if you take k means alpha and beta is there. Both alpha and beta are greater than k. We can find f of k here. Is it? This is where we can find f of k. So in this case, a is what, man? How this graph looks like? What, man? A is the leading coefficient, man. Seeing the graph, you should identify how A is. A is greater than 0 or less than 0. How this graph is? Open upwards. Open upwards means A is greater than 0. How about f of k? That is also positive only, right? It is inserting in yes, greater than 0 only. Suppose it like this, here it is coming, wait man, let me complete. This side if it is coming also means, though the value is negative k, f of k is being positive only. Is it? Because that is the value for y axis, man. F of k will be there in y axis. Here it is k, this is f of k in y axis. Alright. So a into f of k, a is greater than 0, f of k also greater than 0. Their product is what? Greater than 0. The first condition. No, f of k is not discriminant. Okay. Next, we are going to comment on delta. A into f of k, man. Okay, in this case we'll discuss. Here k is there, f of k is here. So in this case, f of k is less than 0 or not? What about a? When we multiply these two, die. One is negative, other also negative. When we multiply those two, positive. It works for both. It's good. Okay. And then delta. What we can say about delta is very clearly. Just listen here. See, we know only one thing. Both roots are greater than k only. It is possible that these both roots may converge. Possible or not? We don't know any details about the in between how it will behave. Is it? So there is a chance that it might get converged. Okay. So if it is converged means it will become 1 0. Is it? Real and equal. Then what is the value of delta? See, I am just freezing for a moment. If delta is what means these two roots will be same, real and equal. Dey Babu, you have to answer. Delta is what means we have real and equal 0. What is the value of delta, man, when the roots are real and equal? Equal to 0. That is possible. It may be distinct also. Distinct roots means delta is okay, man. See, alpha and beta are there, right? They are two distinct roots. Alright. When we will have two distinct roots, delta is what? If we have two real and distinct roots, yes sir. So it may be greater than 0 or it may be equal to 0. We are not sure. So delta will be greater than or equal to 0. Alright. Here also the same scenario. It may be equal. Here also same scenario, man. It is either greater than 0 or equal to 0. So delta is greater than or equal to 0. Here also same scenario. Is it? And about minus b by 2a. Here only minus b by 2a. Yes, sir. No. There will be some glitches, I think. How about now? Okay. Just compare k and minus b by 2a. K and minus b by 2a, man. Where it is the value of k? See the number line simply. Noda babu. See, this minus b by 2a is here. K is here. So which is greater than k. That's all. That is the third condition. There is no k1, k2. We don't need to discuss about this. Okay. Only these three things we can take as the observation. This is when both alpha and beta are greater than k. And if both are, case 2, if both roots are alpha and beta are less than k. Less than k means what? This like it will be here alpha, here beta, k will be here. Is it? Open downwards also same. K will be here, here alpha, beta. Alpha, beta are both cases, man. Open upwards, open downwards. K, I am talking about k, not about a. See, here it is based on both. Three conditions we can derive from this. Simply, see what is the sign of a, man, here? Greater than 0. What about f of k? That is also greater than 0. Here a is less than 0. F of k also less than. Then what is a into f of k? Which is greater than 0. Positive. Alright. Alright. Good. See, a into f of k is greater than 0. Next, about delta, what we can say? We know both are less than k only. Is it? It may converge, may not converge. It may be equal or unequal, right? Greater than or equal to 0. Alright. And what we can comment on minus b by 2a? Minus b by 2a is what? Here it is minus b by 2a. Simply the midpoint. Midpoint is this we call. It is less than k. That's all. Any doubts? Okay, sir. Case 3. If k lies between alpha and beta, k is before alpha beta, k is after alpha beta, k is between alpha beta. Okay. So now the graph. Here k, alpha, beta, open upwards. Here k, alpha, beta, open downwards. Okay, shall I erase this side? No, sir. Just a minute, we'll see. Shall I erase this? Alright. Here, what is the sign of A, man? A is less than 0. And f of k. F of k is greater than 0. Sabo, right? So when negative value and positive value, they multiply together. Here also, man. Here we have A is greater than 0. F of k is less than 0. One positive and negative value multiplied together will get A into f of k is, yes man, A is negative, man, f of k is positive, man. Then when we multiply, we will get less than 0 in both cases. And what we can say about delta? Yes, sir. Yes, that is fine. Yes, that is what I wrote. Less than 0. A into f of k. Negative. Yes. And delta. What we can say about delta? Previous case and all, there is a ambiguity that whether that alpha and beta meets together or not. But here there is a gate between alpha and beta. We surely know one value is there because it is strictly less than. So there must be two distinct roots. There is no chance of equals and all. So delta will be what? Strictly greater than 0. Greater than 0, man. Yes. And about minus b by 2a, we can't comment on it because this k may be here. K may be here also. Is it? That minus b by 2. Not an exact middle. It may be anywhere. That minus b by 2 is exact middle. Okay. So may be equal to, we can say. It's not surely equal to. We cannot say less than also. We cannot say greater than also. Okay. We can't comment about it. Only two conditions. Okay. Okay. And then case 4. There are k1 and k2, both alpha beta lie between k1 and k2. That means what? Below one value we know, above one value we know, alpha, beta, this is f of k2, this is f of k1. Okay. So here a into f of k1, man. Both the cases it will be same only. We will discuss for this case alone. Okay. So a into f of k1, first condition. See, a is positive, f of k1 is what? That is also positive. So it is greater than 0. A into f of k2, that is also positive. Okay. And f of k1 into k2, that is also positive. And what about the delta we can say? Delta is what, man? Why, sir? No, not like that. What you can say about delta, man? Delta is greater than or equal to 0. See the graph, man. In between there is no gate, there is no barrier. They can meet also if they want. Maybe equal, maybe not equal. So equal means equal to 0. Not equal means greater than 0. Okay. That is why delta is greater than or equal to 0. And what we can say about? Yes, we don't know. Look at the previous case. We know surely there is in. It is not sure. Yes. Here for sure we know. K is in between, so they won't meet. Okay. Then what we can say about minus b by 2a? This lies between k1 and k2. Okay. These are all the things you can interpret from this. Case 4. Case 5. All the possible cases. See, man. Here k1 and k2, in between alpha beta is there, right? What if 1 is in between? K1 is inside, K2 is outside. No, sir. See, sir, f of k1, which is negative, f of k2 is positive. So what we can say about a into f of k1, a into f of k2. See, a into f of k1, which is negative, a is positive, so which is less than 0. A is positive, f of k1 is what? Positive. Negative, you mean positive, is it? And f of k1 into f of k2, one is positive, other one is negative. Okay. Same happens when it is downwards also. Here k1, here k2, alpha, beta. Here a into f of k1 is what, man? A is less than 0, f of k1 is positive. So both will be negative only. Same like f of k2 is negative, a is negative. So it is positive. Alright. The same for both the cases. Okay, sir. Both works, man. K2 upwards also is there, downwards also there. But this value remains same. It won't change. Simply they interchange their signs, man. This will be positive, this will be negative in one case. The other case, this is positive, this is negative. Okay. Yes. Here also, both are negative, man. Here, man, f of k2 is negative. A is negative. A is negative, f of k1 is positive. So this is negative fully. This is positive. What about k1 into k2? F of k1 into f of k2. Yes, sir. Alright. Then what we can say about delta? Right, sir. Yes, sir. So delta is? Yes. Okay. What about minus b by 2? Yes. Okay. And then case 6. Right, sir. Really? Okay. Let me take care. See, we have seen both roots lie between k1 and k2, and this any one root between k1 and k2, like we can say any one root. It is same for this here k1, here k2 also. Okay. So this case is one root between k1 and k2. This is both roots are between k1 and k2. Here both k1 and k2 between alpha and beta. You guessed it correct. So here k1, k2, alpha, beta. F of k1 is what, man? It's not 1 minute. In this case, okay, shall I erase this? Yes, both are greater than 0, either both are negative 0, less than 0. Okay, then a into f of k1. A is less than 0, f of k1 is greater than 0. Here a is greater than 0, f of k1 is less than 0. So in both cases, this less than 0. A into f of k2. Here a is negative, f of k2 is positive. Okay. Here a is positive. So, yes, here also a is positive, f of k1 is negative. F of k1 is positive, a is negative. Same like a into f of k2 also. A into f of k2 is, it is also less than 0. Okay. And f of k1 into f of k2. Either both are positive or both are negative. Greater than 0. Alright. Then what you can say about delta? Yes. It is not sure that either alpha and beta may converge. Okay. That is it. Okay. Why we have studied all these things? Yes, we can't. Okay. Yes, sir. See, the thing is, we might know some peculiar details about the roots based on the location. So, based on these conditions, we can find the unknowns. That's all. Okay. Shall I raise this? We'll work out one question. Okay. Okay, the value of A for which each one of the roots of x square minus 4ax plus 2a square minus 3a plus 5 is equal to 0 is greater than 2, or simply they gave one equation, man, and the detail given is each one of the roots are greater than 2. Both roots are greater than 2. Is it possible to find their roots? We can't, because there is one unknown. So, location of roots may be used. We know the location, we don't know the roots. Where the roots are located? A, man. We don't know A, right? Okay. 2 is K. Both roots are greater than K. Both roots are greater than the location, address of the roots. Dubai Main Road, Dubai Kurukasand, likewise. So, this is the address K. Okay. So, the case what you are looking for is, here K is there, here alpha beta, that K is nothing but 2. Yes, sir. See, look at the graph. A is what? Okay. So, here A is greater than 0. We know both roots are greater than 2. So, they may converge. Is it? Okay. Then, first we will list out the conditions and then we will apply. So, A is greater than 0. Okay. And A into f of 2, man. What you can say about f of 2? F of 2 is positive, right? A is also positive. Is greater than 0. And second one, what you can say about delta? Yes, good. Because they may converge. We can't trust them. Third one. Yes, greater than K. That is 2. That's all. All these things we just find which is common for all these three. We note it down. That is the answer. Okay. So, A into f of 2. A is 1. F of 2, man. 2 square. The first condition I am writing. A into f of 2, which is greater than 0. A is 1. Into f of 2 means here we should substitute 2. So, instead of x only I am substituting. Keep in mind. 2 minus 4a into 2 plus 2a square minus 3a plus 5, which is greater than 0. This is what f, man. Okay, and this is 4 minus 8a, okay, 8a plus 2a square minus 3a plus 5, which is greater than 0. Add the like terms. 2a square minus 3a minus 8a minus 11a, 4 and 5, 9, is it? Which is greater than 0. Alright. Now, have you seen this anywhere? Previous aim. Where it is greater than 0, a we have to find range of a. Remember? For this we can calculate the delta. So it is minus 11 square minus 4, a is 2. First we will check, man, delta greater than 0 or less than 0. Based on that only we will see, right? 1 to 1 minus 4 2s are 8, 8 9s are 72. It is obviously greater than 0. We should find the roots. So 2 9s are 18. By multiplication 18, addition minus 11. 9 2s are both negative. So leading coefficient is not 1. Split the middle term. 2a square minus 9a minus 2a plus 9, which is greater than 0. You just see where it is greater than 0, that interval we have to take. Okay, so here we will take a as common, then we will be having 2a minus 9. Here minus 1 as common, then we will be having 2a minus 9. So from this 2a minus 9 is common, then a minus 1. So the roots are what? 1 and 9 by 2. 9 by 2 is nothing but 4.5. Alright. So where it will be negative, we have to check it. It's very easy. Positive, negative, positive. Hey, we are asking. Yes, where it is positive. A will be less than 1 or a will be greater than 4.5. This is equation 1. Yes. A belongs to minus infinity comma 1 union 4.5 comma infinity. Okay. Because we are going to combine all these three. First one only we worked out. Okay. Then the second one. Delta is greater than or equal to 0. Shall I erase everything? Yes, sir. Delta is greater than or equal to 0. What is delta value, man? That means b square minus 4ac, which is greater than or equal to 0. B square is 4a whole square minus 4, a is 1, c is 2a square minus 3a plus 5, which is greater than or equal to 0 we should take. Okay. Now simplify this. Then we will get 16a square minus 4 2s are 8a square minus into minus plus 4 3s are 12a minus into plus minus 20, which is greater than or equal to 0. 16a square minus 8a square, which is 8a square plus 12a minus 20, which is greater than 0. All this can be divided by 4. Sorry, greater than or equal to. Good. Divide this by 4. Then 2a square plus 3a minus 5, which is greater than or equal to 0. Then here also discriminant we have to find. The discriminant is what? B square 9 minus 4, a is 2, c is minus 5, minus into minus it will become plus, so it is obviously greater than 0. We need to find the roots. Maximum of the case we have to find the roots greater than 0. 2 5s are 10, minus 10, addition 3. Find such numbers. Simply 5 2s are 2 gets the negative. 5 into minus 2. Okay. So leading coefficient is not 1. Split the middle term better. So 2a square plus 5a minus 2a minus 5, which is greater or equal to 0. We will see whether it is greater or where it is greater or equal to 0. From these two, a can be taken out. So it is 2a plus 5. From these two, minus 1b can taken out. So we will be having 2a plus 5, which is greater or equal to 0. From these two, 2a plus 5. Why man into a minus 1? 2a plus 5 into a minus 1, which is greater or equal to 0. Then a is equal to 1 or a is equals to minus 5 by 2. So this interval from 1 minus 2.5, where it is greater than or equal to, that's really does matters, man. Greater than or equal to, keep in mind. Okay, so greater than, positive means what? All the leading coefficient is 1, I mean positive. So at last we will start with the positive, alternatively positive, negative, positive will check, and then greater than or equal to 0 means this point also should be involved. Okay, second condition we can found. Third condition, right man, we are going to combine all these three. Yes sir, this is also negative infinity comma, see let me write here, space won't be sufficient. A belongs to negative infinity comma, here open bracket, minus 2.5 open bracket union, so I mean closed bracket. See, I am also saying like that, open bracket, I mean closed bracket. Okay, see, closed bracket 1 comma infinity. Whenever you put infinity, put to open bracket. Okay, and then third condition, minus b by 2a, which is greater than 0. Greater than 2. So which is minus b? Oh, erase the equation. What it is the equation? Minus b is minus of minus 4a by 2 into a. A is what? 1. Don't get confused, man. That a is different, this a is different. If you are getting confused means, let me write capital B. Okay. The equation itself, one a is given, right? Here small a means coefficient of x square. Okay. So which is greater than 2. Then minus into minus will become plus. This can be simplified. So we get a is greater than 2. Okay. We got 3 conditions, man. 1 and this is 2 and this is 3. All the 3 values is come. No man. Yes. Sorry. 2a greater than 2. Then a is greater than 1. Okay. Yes. So that is the third one. All these 1, 2, 3 we have to combine, man. Shall I erase this side? Okay. Now listen closely. Very closely. Just place all the numbers. Whatever the thing we get from the beginning. This is the number line. In the number line, initially we got 1 and 4.5. Okay. Here 1. Here 4.5. Like open interval, right? Greater than 4.5. This interval. And this interval. This is for 1 man. Okay. It is not 1 included. Because it is strictly less than 0, right? Sorry, strictly greater than 0. Look at the first condition, a into f of k greater than 0 only we kept. It is not greater than or equal to 0. If they say r equal to 0 means we should include this point also, because in these points they will become 0. Greater than, strictly greater than, 0 not allowed. Okay. 1 is greater than 0 only, man. If you substitute 1 in this expression means that everything will become 0, right? 0 is positive or negative? Neither. So that is why 1 should not be involved. On the other hand, you see here, we get greater than or equal to 0, right? See, man, here you say the expression, this is a minus 1 into a minus 2a minus 2a minus 9, correct? You substitute 1 in here, what it will become? Then the whole thing will become 0. We are looking for where it is greater than 0. Where it is 0 we want. But in this case, it is greater than or equal to 0. That is why this point also we included. Okay. So that point I plotted on, and then this one minus 2.5, where it will be here. Minus 2.5 and 1 will be here before here only 1. Okay. So we'll be having 1 included with fully, and here 2.5 included and fully. Okay. This one, man. Okay. And then third one. A is greater than 1. Hey, this is for second case, man. And for third case, A should be greater than 1. So which is from here to fully. If we have different colors means put 3 different colors for this. For 1 different color, 2 different color, 3 different color. In a particular interval, all the 3 things will be same. See, look at this interval, minus infinity 2, 2, 5. 1 satisfied, 2 satisfied, 3. This interval out. Minus 2.5, 1. 1 satisfied, 2 not satisfied, out. From 1 to 4.5, 1 itself not satisfied. Only 2 and 3 satisfied, out. 4.5 to infinity, 1 satisfied, 2 satisfied, 3 satisfied. Okay, whether we can include 4.5 or not. In all the 3 cases, 4.5 can be included, means we can include. We can't include. Because at this point it will become 0. At that point it has become 0 or not. 4.5. See, man, 4.5 is excluded here. If you include means 1 will not be satisfied here. Okay, if you include 4.5, this will be satisfied or not. 1 will be angry. So, okay. So, all the 3 is converging here only. So, the range of A is what? 4.5 infinity, which is nothing but 9/2, infinity. Any option like that? No, man. To explaining only, I explained this much. If you are habituated to this, you don't need to write all these steps. Directly you can write the conditions, the equation, and these 3 lines converge. How long? 5 minutes maximum. For the first time only, it takes like 15 to 20 minutes. Okay. See, while you are studying first standard, you takes 1 hour to write 1 to 100. Now, how fast you can write? 5 minutes itself you can write, no. That is how it should be. Okay. While learning, it takes this much time. But when we apply, when we habituate to this, it's easy. Quickly you can do. Alright. We'll solve one more question, but in the next session.